Hello everyone, good afternoon. My name is Gaurav and I work as a program manager on the Chakra engineering team at Microsoft. Today I'll be providing you an insider perspective to Chakra, looking at some of the architecture stuff, performance, and language support that we've added in Chakra. By the way, is everyone aware of what Chakra is? Okay, Chakra is the code name for the JavaScript engine that we shipped with Internet Explorer 9. Just to get you guys started, I had this slide up here, and I wanted to talk a bit about IE6. I know a lot of you have been, supporting IE6. Thank you so much. We are eagerly waiting for it to die down. Without going into more details, I wanted to dig into some of this. Hey, it's been 10 years and stuff. Carter, who's our marketing guy, helped me pull up this. Yep. Neat. Let me just. Oops. Okay, I'm just going to.
For the last 10 years, in my opinion, Microsoft have consistently got it right.
Internet Explorer has been unbelievable because it's so good. What else can I say?
Do they really think that we're going to prefer other browsers? No way.
Internet Explorer set the standards for other browsers. It's the legacy that will not die.
Visually, IE6 set new expectations about the way the web should look. Then IE7 brought along transparent PNGs. And I just said, wow.
There's been a complete lack of problems and frustrations.
Have Microsoft given us the support all the bloody time?
I've always found it plays nicely.
It really is inexplicable how its performance set such a high expectation.
Ridiculously great is how I'd describe their efforts to date.
I haven't
Got a bad thing to
Say about
the old
Internet Explorer.
big
round of applause.
All right. So this is how web developers think about Internet Explorer, and I do not blame them. Yes, it's primarily IE6. Now let's get started with Chakra or the JavaScript engine. When we started working on Chakra, we were sure that we were coming from way behind other browsers. The other JavaScript engines had really caught up. And there were two clear approaches that we could have taken. We could have probably started with an interpreter-based engine, picked up the old engine that IE8 and the previous version started, and kind of start adding optimizations to it. On the other side, we could have started building a compiler, initially not fully optimized, and then keep adding more optimizations as we go along. But it was clear that we wanted two aspects in the engine. The first, we wanted the engine to be a game changer, and two, we wanted it to be forward-looking. Based on the same, we decided, as many of you might know, to build both a completely new interpreter into the engine and a completely new compiler. So why did we do this? We actually looked at the real web as it exists today and some of the forward-looking things. The web can be broken down into two key pieces. Like on one side of the spectrum are the basic web pages, like the my restaurant's favorite site or the Wikipedias of the world. And on the other side of the spectrum are the responsive HTML5 apps, which are really execution heavy and probably interact a lot with the DOM. I call these the developer's playground because these are the kind of apps probably almost all of you might be developing right now. Nobody is any longer talking about static web pages that you are creating. So what did we do different? Let's start with the interpreter. We created a new interpreter which was optimized for the dynamic nature of JavaScript language. We added a completely new optimized type system to the engine. Think of a type system as an internal representation of JavaScript objects. We added type evolution, type sharing, and a bunch of stuff around that. We made sure that we cache property per call site whenever possible. Numbers in JavaScript had traditionally been floats. We made sure that we go ahead and add an integer representation for numbers whenever possible, making sure that we save both memory and speed up the operations as we go along. Just like modern browsers and modern JavaScript engines, we thought that it is going to become, having dual cores on a machine is going to become a norm as we chug along. Hence, we decided that we'll add a compiler, but there are 4 key things that we did to the compiler. One, we added it as a background thread. So what you will see is the compiler does not run in the foreground, it runs in the background. Second, we made sure it's not a very basic compiler, but it's a compiler which does very high quality code analysis and generates highly optimized code. Third, we made sure that the compiler takes advantage of the hardware that it is running on and uses stuff like SSE2 processor instruction set. This is way back old. If any of you've been C++ guys, you would know that Pentium introduced this technology in around 2001. AMD followed up with 2003. All chips currently have SSE2 support available, almost everyone. And we made sure that the Chakra compiler uses the same instruction set to give speed benefits. And the fourth thing that we did in the compiler was make sure that we really integrate it well with our interpreter. So when you're running a particular function and the function execution gets over, the machinery is such that it can switch between an interpreted function versus a compiled function. So let me put it into perspective. I think, yeah, pretty big things, pretty big terms, messy. When you write apps and you run it in any of the browser, a browser is made up of different layers in the stack. For IE, we basically break it down into 11 subsystems. JavaScript is just one of them. Here's a CPU profile when I'm loading a popular Ajax news site, pre-Chakra. 3 things that I would say you should note here. First is that the green color is showing the amount of time spent in JavaScript. 2, note that the site kind of loads in around 6.5 seconds. And 3, you'll see that the second core of my machine, so I ran this on a dual core machine, was largely empty. Like there's some amount of read, some image decoding going on here, but that was almost about it. And when we bring in the Chakra hybrid architecture of having both the interpreter and the compiler, here's what you will see. Well, what's happening here is when you start loading the page, the interpreter starts chugging along. It starts interpreting code, and that's what you see here. The second thing that you will notice is that the compiler starts running on the background thread and uses the background CPU to the optimum level. Third, you will see that the actual time spent in JavaScript code has reduced as we go along. The key reason for this is that when JavaScript is called, when JavaScript is already compiled, you have the compiled functions available. At a certain point, the interpreter will just stop and start calling the compiled code. And it's the compiled code which runs, which obviously takes less amount of time. And the fourth thing you'll notice is that the site now loads in less than around, in less than 5 seconds. Now, this loading in less time is not only because of Chakra, but even about, because of some of the other optimizations that we've done in IE9, including stuff around, hardware accelerated graphics. But this is just, a view of how Chakra actually impacts the engine, the performance of the browser. Now, we made sure we had this hybrid machinery. We had, an interpreter and a compiler running in tandem. We wanted to do a few more things in Chakra. One, we wanted to make sure that it does minimal work in critical paths so that the apps that you write, it can adapt to the patterns of the apps that you write. Obviously, no 2 developers write the same piece of code. So the engine has to be smart to make sure that, hey, I am doing the right set of things at the right time. So 2 key things that I'll call out here. We do not compile all code. We do selective JIT compilation. What that means is if there are 2 functions executed, suppose function A is getting executed time and again, and function B is not getting executed at all, the JIT compiler analyzes the code, figures out the hot paths, and makes sure that function A is prioritized higher for compilation before function B. Next was the concept of deferred parsing. What it meant was internally in the engine, when you bring down a lot of code, you don't need to parse all of it and generate abstract syntax trees for the entire code. A lot of times, sites bring down a lot more JavaScript code than they actually end up using. And this is very common to understand from the perspective of library usage. Let's say I use a particular framework and I include it in my app. Now, I'm not going to use all the APIs that it's providing. I just might want to use 1 or 2 APIs that it is using. As you can see, some of the very popular websites, they're typically not even using 50% of the JavaScript code that they bring down. So let's look at a code sample to understand how some of these things work. So I have a very trivial piece of JavaScript code here. All it is doing is it has a function pattern matcher. This guy basically finds the location of a particular pattern within a string, does it a number of times. Let me just reduce this. I'm calling it 20 times to figure out how much time does each of these calls take, and then just have a graph generated out of it. So let's see. This is the result that Chakra produces. So how do I interpret this? Actually, initially, when you start execution of this, you'll see that Chakra started interpreting the function. In the second and the third iteration, it figured out that, hey, probably there were certain things that I could have cached, so it caches all of those things, and you see speed gains coming because of inline caches kicking in and stuff like that. And by the time the 3 executions are over, you'll see that the time actually drastically drops. It's almost a 2x, more than a 2x drop from the peak time when it was actually running interpreted. And this is because now the compiled code is ready, and instead of just interpreting the functions again and again, the execution machinery just calls the compiled code. Now, just as a comparison, I really don't want to bring this up, but just as a comparison, if I was running the same piece of code in pre-Chakra era, the interpreter was taking somewhere around 250 milliseconds. So, and in Chakra, you'll see that it's around 100 milliseconds. So that's the first gain there itself in the interpreter, which we did not want to. Now, you might have a question as to, hey, you had this cool thing, but why was it even getting interpreted? It was a pretty small piece of code. I think the key thing here that I actually hit initially was, as a bad program, it's supposed to be a bad programming practice that, hey, whenever you're including library files or frameworks, don't include it right at the top. In this particular sample, I just included it at the top. So what it's happening, it's messing with the deferred parser there, which is saying that, hey, just wait, this might not be the first thing that I actually need to go parse. So if all I do is move these framework inclusions right at the end. Okay, thank you. And rerun this. So you'll see there's the speed improvement. It was bang from the first time it was compiled, but there was a gain that came between the first iteration and the second iteration, and that was basically because at the first time you don't have any of the values cached, etc. So that's the speed gain. Moving on, one of the other important aspects of working inside a browser that's pretty old, there are both gains, pros and cons. Like one of the things that the old JavaScript engine brought about was the fact that it was not very tightly integrated with Internet Explorer. With Chakra, we made sure that, hey, we're not going to look at any of the other hosting scenarios, but web is the thing that we're going to look at. There are a couple of things that I want to call out here. First one is Chakra introduced native UTF-8 support. What it basically means is when you guys write your code, it's mostly UTF-8 character encoded. The previous engine never understood UTF-8 natively. It only had UTF-16 support. So to work on that code, it'll always convert UTF-8 to UTF-16, convert it back, and so there's a lot of time. The second key thing that we introduced was we made sure that we reduce the marshalling cost, which is actually the time the JavaScript engine takes to call any of the DOM APIs and back, and completely remove the COM piece. Two key things here. DOM objects are now native JavaScript objects. And what it means for developers is the fact that DOM programmability is now pretty enhanced. Quick look. if I just hit F12, go to my i9 standards mode, so, document get element by ID is now an instance of function. Yeah, the other JavaScript engines had this kind of capability long back, but with spec IDL coming online and the DOM L2 integration with the chakra, we kind of now have all of this support, and DOM objects even have ES5 support enabled now. So, given that I'm running out of time, a few quick things. There's the whole updated i9 web platform. There's a developer guide available, features that you guys can go ahead use. I'm not going to go deep into it. In i9, the Chakra engine supports all of ES5 except for strict mode. Again, I'm not going to go deep into all of this, but just bring up a couple of interesting things about ES5. Once we were developing Chakra, few quick things that we realized as we were working on it is that interoperability is often more than standards. When we released we released platform preview 3 for i9, which has ES5. Couple of examples I picked up as feedback that came from the community, or issues we found while testing stuff. ES5 actually changed the way that when built-ins are supposed to behave when you're sending in nulls or undefineds. This apparently broke the jQuery code that is up here. The key thing was that the jQuery code could have been changed to add or verify the OBJ check here, but a lot of machines already had the jQuery code and it was actually not going to work. So what we did was, Alan, who's sitting right here, who's the editor of ECMAScript 5, he was with Microsoft at that time, and he spun up a thread, talked to all the technical committee members, made sure this got fixed in the ECMAScript 5 spec. And finally, the spec was rectified to make sure that we had a special representation, especially for null and undefined. Here's another one. ECMAScript 5 did not want to break the web, but there are certain features that basically are really implementation dependent, and it's very hard to get them on a single platform. Function declarations within control structure statements are supposed to throw syntax error per se, but none of the implementations do that. We let that behave the same way in i9. One of the constant feedbacks that we've been getting about i9 is the lack of support of const. This was one of the features that ECMAScript 5 technical committee decided that, hey, we don't probably have time to look at in this particular version. We'll do it in the next version, and they, left this unspecified. We decided we'll not go ahead and implement this because the different implementations there were actually doing a lot of different things, like, hey, is this supposed to produce a runtime error, a syntax error, or it's going to treat it just like a var, or do something else. So we decided we'll not go ahead with this. So what does all of this mean for web developers? I think one of the key things here is the fact that just like language specifications, we have standardized language test suites. One of the things that we've been working with the ECMAScript technical committees is to make sure that we have a standardized language test suite. This test suite is still not in its beta state, but here you can go take a look at it. You can go probably run a bunch of tests, pause it, go look at the results, and even join the mailing list. And so currently this particular test suite is not accepting direct submissions from the web developer community, but there's the thought that, hey, probably going ahead, this might change. So this is really the way we think that we need to get interoperability into JavaScript. And as a matter of fact, while developing all the ECMAScript 5 features, we've submitted more than 5,500 tests that we developed to this particular test suite. And we really look forward to this getting into a beta stage and then chugging along from there. Quick question, how many of you have tried i9? Wow, that's quite a lot. How many of you have tried i10? Cool. So we actually released a platform preview 1 of IE9 a couple of weeks back. One of the biggest features that we added there was strict mode. We see this as a feature that helps developers write good quality code. You can have it at a global level, have usestrict defined at a function level. Now, there are certain things that using of eval as an identifier, for example, if you have this and you're running your code when you're running it under strict mode, it's supposed to throw errors. So we really see this as a feature for the developers, and I go ahead and would recommend that you guys try this out. And this kind of brings me to the end of my talk. Thank you.